All right, for 5.2, we're going to talk about what an arc is, an arc of a circle, and also how to measure arc length. But first, let's start with a vocab word or vocab phrase, central angle. And it is one of those vocab words that's exactly what it sounds like. So it's an angle, and it's an angle inside of a circle where the vertex is the center of that circle. So right here, here's a picture of one and another good description. Another good way to think of a central angle, if you take a circle and draw in any two of its radii, that automatically creates a central angle, like we see in black there. Now, the other thing in that same picture, I took the picture and slid it over to the left there. That part of the circle that I marked in red there, it actually says the word right there. That's called an arc. So an arc is part of a circle. If you take any circle and just say, I'm just going to look at this part, just from here to here, that's what we call an arc. Now the red arc in this picture, to be a little bit more specific, is what we call a minor arc. Because it's minor means smaller. So basically any arc that's less than half of a circle is called a minor arc. And the reason that's important, because even though we sometimes don't think of it this way, the green part of the circle is also an arc. It's what we would call a major arc because it's more than half of a circle. So in this picture that we've been looking at, it actually has two arcs in it. The red one is a minor arc, the green one is a major arc. Now the only other possibility, if something isn't more or less than half a circle, it would be if it was exactly half a circle. And we have a name for that. It's called semicircle. And that makes sense too. The prefix semi means half. Semi means half of something. So semicircle means half a circle, and it's not a major arc or a minor arc. It's exactly a circle cut in half. So there are two ways to measure arcs. One of them is using degrees, just like we measure angles. And that's called arc measure. So there's a difference between arc measure, which we're doing right now, and arc length, which we'll get to in a minute. Arc measure is measured in degrees, and it's very simple. An arc's measure is the same as its central angle's measure. Meaning, if we go back to a picture like that one before, where I drew a central angle, this time I give you a number. I said the central angle is 85 degrees. Now, that means the arc in between that angle right here, this arc right here from P to Q, I'll highlight it in red there, that arc also equals 85 degrees. So I said in the picture, the measure of, and this is a new notation for us too, this notation right here means arc. If I write two letters and instead of drawing a flat line over it for a line segment, if I draw a curved line like an arc over it, that's our notation for arc. So in this picture, the measure of arc PQ is 85 degrees because the central angle that makes that arc is 85 degrees. All right. One interesting thing about circles is that the angles, like let's say we're talking about central angles again, the central angles of a circle always add up to 360. If you're facing one direction and you turn 360 degrees, you've turned one full rotation and you're facing the same direction again. Now, if there's 360 degrees in a circle, then that means the arcs always have to add up to 360. So let's say in that picture from before, I wanted to talk about the major arc instead of the minor arc. So what I could say, and here's that picture again, let me color it in again like I did on the last slide. Let's say I wanted to talk about this arc right here, and I'm highlighting in red. So number one, notice here I used three letters. If I say arc PQ, that means get from P to Q as fast as possible, the shortest way possible. So arc PQ was the one we did on the last slide. If I say arc PRQ, you have to go through those letters in order. It has to start at P, go through R, and end at Q. And that's how you know I'm talking about the major arc instead of the minor arc. Now the other thing is we can easily figure that out by just subtracting from 360. If there are 360 degrees in a circle, and the minor arc is 85 degrees, I can do the major arc by just doing 360 minus 85, and I get 275 degrees. So the measure of arc PRQ, the major arc in this picture, ends up being 275 degrees. All right, now let's talk about arc length. So length and measure, it sounds like it's the same thing, it's not. Arc measure is in degrees, arc length is a distance. It's going to be like 10 miles or 3 feet or 2.7 inches or something like that. So all of a sudden, it's tied in with circumference again. The circumference is a distance around the circle in distance, inches, feet, meters. Arc length is going to be that distance, but just the arc instead of the whole circle. So we know from day one, from 5.1, that the circumference of a circle is 2 pi r, or it could be pi d, but I'm going to go with 2 pi r for this one. And we just learned that a whole circle in degrees is 360. So what you can do is you can kind of think of it like proportions or percentages. If you take the arc's measure in degrees and divide it by 360, that tells you how much of the circle you're using, which is like a percentage. You know, if the angle's only 10 degrees, you do 10 divided by 360 to figure out how much of the circumference you're looking at. So basically, let's kind of put together a formula for arc length of AB, we'll call it. So what I did, I took the measure of angle AB and I divided it by 360. That's where I was saying what we're actually doing here was figuring out like a percentage, how much of the circle we're using. Then 2 pi r is the distance all the way around the circle. So what I'm doing is I'm saying, okay, right here, this is the distance around the whole circle. And right here, this is how much of the circle I'm using. If it's 90 degrees, it's 90 out of 360, or 90 divided by 360. So we're using fractions or proportions to determine how much of the circumference to use. But really it's a formula. It's the measure of the arc, or the central angle, which is in degrees, divided by 360, times the circumference. So let's try one out. Let's find the length of arc PQ. So first of all, here's point P right here, and here's point Q. Now because I only use 2 letters, you know it's the minor arc. It's the fastest way from P to Q. So I'm talking about this arc right here that I'm highlighting in purple. Now once I realize that, I have everything I need. This is going to be the same as the arc measure, 135 degrees, and this right here is the radius. So if I do the measure of arc PQ divided by 360 times the circumference, which is 2 pi r, that'll give me the arc length. Now, the measure of PQ is 135. 2 pi times the radius, which is 12. So what we have is 135 over or divided by. You can use fractions or divide. I probably would divide. I would probably grab a calculator and do 135 divided by 360 times 2 times pi times 12. Crank it all into a calculator, we'll see what we get. So I'm going to pause and do that work. I'll be right back with the answer. All right, and I got about 28.27 for that one on the calculator. 28.27. So remember, think of it as 2 parts. Number 1, you're finding the circumference of the circle. That's the 2 pi r part. But then instead of taking the whole circumference, you're saying, well, I'm not using the whole thing. Out of the 360 degrees, I'm only using this much of it. And that's where the fraction, that's where the 135 over 360 comes from. Okay, let's flip the example. So here's a different picture. This time I gave you the arc length, and we're going to find the radius. So let's put our numbers in. I gave you the arc length, so I said arc length of AB, I'm going to mark it in red again. From A to B, the short way, minor arc, is 10. Right here is our angle, that's our arc measure. and we want to find the radius. So what I'm going to do, let me start with the formula again. I'm going to have the measure of arc AB over 360 times 2 pi r. Now here's the difference. Instead of just plugging numbers in and typing out on a calculator, I have an equation. See, I told you the answer to this question. This equals 10. I'm going to plug in numbers for the angle. I'm going to plug in one number for the angle, and I'm actually going to solve for r. So let's do that. Measure of angle AB is 60. So now what we have is 60 over 360 times 2 pi r equals 10. It's not quite as easy. You don't get to just type it into a calculator. So let's reduce first. Actually, 60 over 360 reduces real nice. That's 1/6. And if I multiply 1/6 times 2, I get 1/3. So what I have is 1/3 pi r equals 10. So I just did a little bit of simplifying. Now what I want to do is I want to solve for pi. The first thing I'm going to do, I want to cancel out a 1/3, so I'm going to multiply by 3. Multiply both sides by 3, because 3 times 1/3 reciprocals cancel. And what I get is, I'm going to move over here under the circle, I'm running out of space. I get pi r equals 30. 10 times 3 is 30. Then to finish solving for r, I'm going to divide both sides by pi. So I have my answer. What I need to do is pause one more time, go back to my calculator, and figure out what 30 divided by pi is. And it's about 9.55. So the radius of that circle was a little bit over 9.5 for that one. But you can see the difference. Arc length is a pretty easy formula. Angle divided by 360 times circumference, basically. If you're finding arc length, you just plug the numbers into a calculator, you got your answer. This one's a little trickier. This one took some work. You had to realize I gave you the arc length. We have an equation, we're solving for r, and you can look through the work. I plugged in my numbers, I simplified, I multiplied, I ended up being pi r equals 30, and I divided both sides by pi to solve.